Okay, welcome back to my class, dear student. This is my second lecture. Glad to be back here. As previous class was my first class, so I might a little bit, with the adjustment of the camera. But I hope today everything will go perfectly. And because of shortage of time, I could not explain it properly. The last topic, the relation between R and F. R means the radius of curvature, and focal length. So today I'm going to just give you a quick review and I'll explain everything in short. Okay, so let's start the class. As those who are watching for the first time, please watch the first video so that you can get all the basics. Okay, so relation between R and F. So relation between radius of curvature and focal length. So as you can see, this is the diagram. Okay, this is the diagram. So this is for concave mirror. I'm drawing concave mirror, but the same relation you can derive from the convex mirror also. So dear students, as you can see, okay, this is a parallel paraxial ray strikes the mirror at point M, and as this ray is parallel to the principal axis, so after reflection it will passes through the focus, as you have already learned in your class 10. Okay, so whenever I join this point of incidence and center of curvature, you always think that this represents the normal to the point of incidence. So here I am writing, let us consider a parallel paraxial ray strikes the mirror at point M. So let C be the center of curvature. As already I have explained what is center of curvature. It is the center of the sphere. So here, as you can see in the diagram, so angle MCD, right? Angle MCD is what? Angle theta. And angle MFD is what? Twice theta. So here I am writing theta. Why? Because see, this is incident ray and this is reflected ray. And according to the law of reflection, angle of incidence is always equal to the angle of reflection. So this is very basic thing. Okay, now come to the mathematical part. Okay, so from the figure, I'm considering two right angle triangles. So this is CMD, right? Delta CMD. And if you have time in the exam, so you can write from the right angle triangle delta CMD and delta FMD we have. So first, in this particular triangle, CMD will first apply the tan rule. As you can see, I'm writing tan theta. Why? Because I'm considering this angle. Okay, so as we already know, what is tan rule? Perpendicular by base. So here you see tan theta equal to, perpendicular is this MD divided by what? CD. Okay, so I'm writing MD divided by CD. Okay, now focus on this particular point. So whatever we are going to discuss in this class 12 syllabus, all the rays will be paraxial rays. So for the paraxial rays, tan theta is approximately, tan theta is always, or we can consider theta, or whenever you get sine theta, you can consider theta. So that's why I'm tan theta. In next step, I'm writing theta. So theta equal to MD divided by CP. Why I'm writing CP? Because you see, for the paraxial rays, the gap between D and P, this is negligible. This gap is what? Negligible. So this point practically almost coincide with each other. So that's why CD we can write CP. That's why I'm writing theta equal to MD divided by CP. I'm referring equation number 1. Okay. Now next. Now again we are considering delta FMD. Where is delta FMD? This is FMD. So again we are applying tan rule. So tan, the angle is how much? Twice theta. So I'm writing tan twice theta. Perpendicular by base. So MD divided what? MD divided by FD. Okay, but as I told you, tan we can equate to twice theta. Why? Because this is paraxial rays. So tan twice theta equal to MD divided by, in place of FD, I'm writing FP. As I have told you, this gap is negligible. So we can write MD divided by FP. So theta, we got the value of theta. If you check the equation number 1, theta equal to MD divided by CP. So in the next step, I'm replacing the value of theta by using equation 1, MD divided by CP. So you see, MD we can cancel out. So I cancel out MD divided by MD. So in the whole processes, we are dividing the whole equation by MD on both sides. First, it's a simple algebra. So 2 divided by CP equal to 1 by FP. Now I inverse the whole equation. So numerator becomes denominator and denominators become numerator. So C by P, I'm making it CP by 2. So here 1 by FP, so it becomes FP by 1. Okay, I hope it's clear. Now what is CP? CP is nothing but, it represents the distance between center of curvature and the pole. This is nothing but radius of curvature. And next, FP. FP is nothing but the distance between pole and the focus. So it represents what? Focal length. So it's simple. So R divided R by 2 equal to F. This is the relation which represents, this is the relation that we have to deduce. So we can write F equal to R by 2 also, or you can write R equal to twice F. So this is the conclusion. Okay, but as I told you, this is only for paraxial rays, but it not necessarily be only for paraxial rays. When you go for entrance exams, like NEET and JEE, this simple question is not going to ask you. They are not going to ask you the simple question. So here you see actually the standard equation that represents the relation between R and F is R equal to R minus R divided by twice cos I, which represents I is the angle of incidence. This is the standard formula. And we can modify this formula for what? For the paraxial rays. As I told you, for the paraxial rays, I is very small, right? I is very small. So if I is very small, it means it's almost equal to 0. So your cos 0 becomes 1. Why? Because I is very, very small. So we can write cos theta equal to 1. So if we put these results in the standard equation, so this 2, what is the value of cos I now? This becomes cos 0, so this is 1. So R equal to, if we take LCM, twice R minus R. So sorry, this should be F, okay, sorry, F. So F equal to R by 2. So this is for paraxial ray that we have just deduced. So why I'm telling this one? Because sometimes some questions might ask you in the engineering entrance exam as well as in the medical. So I'll give you one example. One question has been asked in JEE, especially in mains for NITs, okay? The question was like this. They have given you the angle of incidence and you have to find the focal length. So if you try to use that particular formula, you won't be able to find the focal length of the concave mirror. Why? Because they have given you the angle of incidence. So you have to apply this formula, R equal R minus 2 into cos 45 degree. As you know the value of cos 45 degree, this is 1 by root 2. If you solve, you will get the answer. I hope you are very clear about this topic. So now we switch to another topic. I'll tell you one more basic thing that I forgot to discuss in my first class. This is focal plane. Focal plane. So what is focal plane? Let me explain with the help of diagram. So this is a concave mirror again. Say this is pole, and say this is center of curvature. Okay, so this is focus. Okay, let these two are the parallel paraxial beam of light. Parallel paraxial beam of light, so it strikes the mirror at this particular point. So after reflection, it will pass through like this. And say this is focus. Okay, so this is the point of intersection between the two reflected rays. So what is focal plane? Okay, so first for the definition of the focus. Okay, for the definition of the focus, we have already discussed that when the parallel paraxial beam of light after reflection, if they converge at particular point, that particular point is called focus for the concave mirror. But it's not necessary that all the rays should be parallel paraxial beam of light. Sometimes, what if the parallel beam of light strikes the mirror by making some angles like this? See, they are making some angles with the principal axis. So when the parallel paraxial beam of light strikes the mirror by making some angle, okay, so after reflection means you can say the reflected ray converge or appear to converge or appear to diverge from a particular point in a particular plane perpendicular to the focus. So that particular plane is called focal plane. So you have to remember that all the rays not necessarily be parallel paraxial beam of light. Okay, so sometimes they might make some angle with the principal axis. Okay, sometimes they might make angle with the principal axis. So in this particular case, we'll get the focal plane. So if you need the good definition, you can go through the book, but I'm just explaining you the particular concept. So we learned focus for concave and convex mirror as well as focal plane for concave mirror, and if you want, then you can go for convex mirror also. Just I am giving you the particular concept. So this is done. So now we'll discuss the next topic. So next topic is very important. This is mirror equation. This is what? Mirror equation. So we'll derive the mirror equation for concave mirror. But same goes to convex mirror also. So because shortage of time, so you try to solve by yourself for the convex mirror. So first let me draw the diagram. So this is a concave mirror. This is a principal axis. This is pole of the mirror, and say this is center of curvature, and this is focus. As I told you, in exam you have to use compass, scale everything. Okay. So this is parallel paraxial beam of light. So this is the object. This is the object. The object, say this is AB, is placed beyond the center of curvature, and you have to remember one thing. When we place the object beyond the center of curvature, you have to make sure that your image should be formed in between center of curvature and focus. So if your object or if your image is forming somewhere in this particular point or in this point, means your diagram is wrong. So when you place the object beyond the center of curvature, your image must be formed in between center of curvature and focus. Okay. So when the parallel beam of light strikes the mirror after reflection, they will always pass through the focus. This is the rules for drawing ray diagrams. Okay, so this is parallel and after reflection passing through the focus. And next, say, let us take another point, another ray. So after reflection, suppose it will pass through this point by obeying the law of reflection. So here is the intersection point of reflected ray, so we can consider this is the image formation. Okay, this is what? This is the image formation. So this is A dash, sorry, this is A dash and B dash. Okay, so first, before deducing the equation, let me tell you what is image. Okay, so image, suppose from any point source, so light is coming from any point source. Light is coming from any point source. It may be artificial or it may be natural sources. So suppose the light is coming from any source, and after reflection, if they converge or if they diverge from a particular point, okay, so here at the particular point the image will form. So we can say the image is the point to point correspondence that established through the reflection or refraction of light. So remember one thing, what is image? Image is nothing but the point of intersection between the two reflected rays or two refracted rays. But there are two types of images, as you have already learned. One is real image, another one is virtual image. So what is real image? Image is real when two reflected rays or two refracted rays actually intersect or actually converge to a particular point. And what is virtual image? So virtual image is that when the two particular rays after reflection or refraction, they do not converge at a single point, or they do not meet at a single point, but they appear to diverge from a particular point when produced backward. These kind of images are known as virtual images. So and one more difference is that we can place the real image on the screen. Like the very common example is that when you go to movie theater, you can watch, the movie theater, the pictures and all, the moving pictures, these are the real image. And virtual image, the virtual image we cannot place on the screen, or we cannot conceive them. So the very common example is that when you see your face on the plane mirror, what type of image is formed? This is virtual image. And one more thing, how to identify from the ray diagram the image is real or virtual. The very shortcut point is that if you want to identify the image is real or virtual, you just focus on the image. Okay, see, now you see the head, this is the head, and what about this image? This is upside down. So if this is upside down, if the image is upside down with respect to the object, so this is real image. And if the image is erect, and this is virtual image. So I hope it's clear. Okay, so always remember one thing, real image is always inverted and virtual image is always erect. Okay, now let's deduce the formula. Okay, so this is for the sign convention. Okay, this is x dash, this is y y this. So this is positive side, say this is origin, okay, this is negative side, and this is positive, and this is negative side. And you just always remember, it doesn't matter whether this is convex or concave mirror. In your mind, you always place the mirror at the origin of the Cartesian coordinate system. So all the distances to this side will be taken as negative, and all the distances to this side will be taken as positive, and all the distances above the x-axis will be taken as positive, and all the distances below the x-axis will be taken as negative. So if I tell you, if I refer this coordinate system in this particular ray diagram, so all the distances, if we measure in front of the mirror, so all the distances will be negative. And if you go to that side, then all the distances will be positive. And with respect to this principal axis, the principal axis refers to the x-axis. So above the principal axis or above the x-axis, the distance will be considered as positive, and below the x-axis or below the principal axis, the the measurement will be taken as negative. Okay, so this is the diagram for mirror equation. So how we explain the diagram? Okay, so it's very simple. So you just write, okay, the figure shows the geometry of the image formation by the concave mirror. So A dash B dash be the real image formed by the concave mirror for the object AB. Okay, this is the simple explanation, and you can go through the book. Okay, now I'll tell you only the deduction part. Okay, now let's deduce the equation. Okay, so remember one thing, here also the rays are paraxial. Okay, so whenever you write the explanation, you always mention that let us consider a parallel paraxial ray of light or beam of light. Okay, so let's consider this triangle. Okay, from delta, this is right angle triangle. If you have time, you can write from right angle triangle. This is focus, okay, this is focus. So from delta B dash A dash F and delta, say this is point. Okay, so from delta, which one you can take? FMP, FMP, V have. Okay, so now as you can see from the diagram, this is curve, but for paraxial ray, you have to think that this is straight line. Okay, is it clear? MP you can consider as a straight line because rays are paraxial. So we have what we can write. Okay, so these two triangles are similar. Okay, these are what? Similar triangles. Okay, these are what? Similar triangles. So in exam you can write from the similar triangle delta B dash A dash F and delta FMP V have. So what if the two triangles are similar? Their proportion or the ratio of the sides are equal. So what we can write? We can write B dash A dash divided by MP. So this is MP equal. So this is B dash F. Proportion ratios are equal. B dash F equal divided by FP. Okay, now as I told you, this is straight line and this is parallel. These two lines. Here I am drawing these two rays. These are the two particular rays. Okay, so if the rays are parallel at any point, their distances must be equal. This is the meaning of parallel rays. So we can write AB is equal to MP. So here B dash A dash divided in place of MP we can write AB. Okay, or if you want, then you can write BA. That's and B dash F divided by FP. So here you have to mention clearly, since BA equal to MP, or if you want you can write for paraxial rays. So this is equation number 1. Okay, next. Okay, here this is incident ray, and for this incident ray this is reflected ray. So according to law, angle of incidence must be equal to angle of reflection. So this angle is equal. These two angles are what? Equal. So this particular triangle, so right angle triangle ABP is similar to A dash B dash P. A dash B dash P. So again, so you can write end from similar triangle, or you can say similar right angle triangles delta ABP and delta B dash A dash P we have. Okay, so why they are similar? Because these two angles are equal. You can mention that since angle APB equal to angle B dash PA dash, therefore these two triangles are similar. So again similar triangle, so what we can write? So again ratio of the sides are equal, so B dash A dash divided by BA equal, so B dash A dash equal, divided by BA, and what we can write? B dash P divided by BP. So you just refer the triangle. Okay, I hope it's clear. Okay, now we check the equation number 1. From this equation number 1, you check the left hand side, B dash A divided by BA. Here also B dash A divided by BA. So B dash A divided by BA can be replaced by B dash F divided by FP. So we'll replace this. B dash F divided by FP equal to B dash P divided by BP. So here you have to write using equation 1. Okay, I hope it's clear. Okay. Okay, so if you guys have done this one, so I will erase this part. Okay, so because not that much space. Okay, so now B dash F. Now you check the diagram or check the ray diagram. B dash F. Okay, so B dash F. Now you take this particular line. So B dash F and this is P. I'm assuming this line B dash P. So B dash F and P. Okay, so from this particular line B dash F can be expressed as B dash P minus FP. I hope it's clear, because you see, because this is B dash P, right? The whole straight line is B dash P, and we need this particular point. We need this what? Particular point. So what you have to do? So you have to subtract this part. So that's why from the whole straight line you have to subtract what? FP. This is not part of the deduction. I'm just explaining you. So in place of B dash F, what we can write? So this is B dash P divided by FP divided by FP equal B dash P divided by BP. So I hope it's clear. Okay. Now this equation represents the relation between image distance, object distance, and focal length, but in magnitude only. So why? Because you see B dash P represents the image distance. How you see? See here is the image. So every distances, you have to remember, every distances will be measured from what? Pole of the mirror. So see, this is the image. So from this particular point, B dash represents what? The distance of the image from the pole. So we can consider B dash P is what? Image distance. And next, FP. So what is FP? This is focus and this is pole. This is nothing but the focal length. And next is what? Next is, BP. So here is the object. So distance of this particular point from P will represent the object distance. So this relation will represent what? The relation between image distance, object distance, and focal length, but in magnitude. Okay, now we apply the sign convention. Okay, so you have to write here applying sign convention. So you don't get confused about sign convention, as I already told you. Okay, so this is a sign convention. We are going to use this. Okay, now for the sign convention, B dash P. So B dash generally, okay, as you have already learned, okay, so B dash P, this is image distance. So image distance is always represented by V. But about the sign, because this is on the left side, right, on the left side of the origin. So this part, according to this should be minus. All the distances will be minus. So I have to put minus here. So again, BP represents the object distance. Again, this is on this side, so this is also minus. And FP, again, the same side. Again, this is focal length, but this is also minus. So now we'll put all the values in this particular equation. Okay, so if you want, then you can give equation number 1. If you don't give also, that's fine, no the problem. So minus V minus, by by equation minus is there, okay. By expression minus is there. Now the value of Fp is minus F, and again Fp, so minus F. Next, B dash P is minus V, Bp is what? Minus U, okay. As you can see, minus minus will cancel out, right? Okay. So here, minus V, minus minus what? Plus, and minus F, and V by U. So the next step, is the simple algebra. So we'll do cross multiplication. So minus VU plus FU equal to minus FV, okay? It's clear? So we are doing cross multiplication. So now next step you can write dividing the whole expression by UVF. So dividing whole equation by U, V and F, okay? So I'm not going to write this one because shortage of time. So minus VU divided by UVF plus FU divided by UVF equal to minus FUVF. Okay, is it clear? Now you can cut the like terms. U cancel out, So F we can cancel U. So F V. Okay. Now after cancelling out, we got minus 1 by F plus 1 by V equal to minus 1 by U. Okay. So we'll arrange the equation so that it looks good. Okay. So I'll transfer this term to the other side. So if I transfer to this side, or if I shift this particular term to on this side, so minus will become plus. So I can write 1 by U. Minus will become what? Plus. If we don't write anything, that term is positive. So this is 1 by V. And I'll transfer this minus 1 by F to the other side. So this is minus term, so it will become plus. So 1 by F. And this particular relationship, right, as you can see, 1 by U plus 1 by V equal to 1 by F. This represents the relation between image distance, object distance, and focal length. Okay, now one thing you have to remember, this relation is true for any kind of image, means whether the image is real or virtual. And this particular equation is true for concave as well as convex mirror. Okay, I hope it's done. Okay, is it clear? Okay, so next topic for this, again the same equation will, okay, now here, okay, one more thing, okay. The size of the object means the relation, size of the object and size of the image, the relative, their comparison, okay. The comparison between the size of the image and the size of the object. This is again a very important, parameter, right? When you compare the size of the image and size of the object, that particular parameter is called, in our book, this is linear magnification. But guys, you see, okay, if you go for the entrance, NEET or JEE, there are two types of magnification. One is linear, another one is transverse. But in this syllabus, we'll discuss only the linear magnification. Okay, so let me give you the definition. So our next topic is linear magnification. So I'm writing here. So this is linear magnification. Linear magnification, okay. Linear magnification in our book, it is denoted by small m, okay. So I'm not going to write the definition, okay. So the linear magnification can be defined as the ratio of size of the image to the size of the object. Is it clear? So I repeat, the linear magnification can be defined as the ratio of the size of the image to the size of the object. Say the size of the image be h days divided by size of the object be h. And in some other book, okay, they might give you m equal to I by O. Is it clear? I represents image and O represents the size of the object. Okay. So now we'll find the relation of this linear magnification with the help of, means with respect to image distance and object distance. Okay, so we have 5 minutes left. Okay, so still we'll try to derive the equation, okay, for this one. Okay, m equal to h dash by m equal to h dash by h. Okay, so again you can write again from delta b a b p and these two triangles are similar, that's why I'm considering these two, B dash, A dash, and P, V have. You have to write V have, V have, or you can write V get. Okay, now you might get confused why I'm taking these two triangles, because I need the size of the image, or size of the object and size of the image. Okay, so from this triangle, so we can write B dash A dash BA equal B dash P divided by BP. Okay, is it clear? So B dash A, size of the image, H dash, size of the object, this is H, equal B dash P is what? Image distance. BP is what? Object distance. Okay, now here H dash must be negative. Why? Because this is below the x-axis or below the principal axis. So here minus minus we can cancel out. So I can write H dash divided by H equal to V by U. Multiplying on both sides by minus. So minus minus it will become plus. So H dash by H equal to minus V by U. Now you see H dash by H is nothing but the linear magnification. So I can write M equal to H dash by H equal to minus V by U. Okay, sorry. So this is the relation. Or you can write in short M equal to minus V by U. Okay, is it clear? So this is the whole equation. Okay, so in exam, okay, this is very important for 2020 because it's been more than 5 years. It's like they are not asking this question in the board exam. So you can, for this, upcoming 2021, you can think that this is important. Okay, so one more thing, okay. So M, okay, by observing the value of M, we can tell them the image is real or virtual. Okay, if your value of M is minus, so that image is real image. Okay, as here, okay, you see M equal to minus V by U. This is negative, right? As you can see from the diagram, this is real image. Why? This is inverted, this is upside down. And suppose in numerical, if you get M is positive, it means that that image must be virtual image. As I told you, real image is always inverted and virtual image is always erect. Okay, I hope it's clear. So today is the shortest of time. So next class, we'll try to express this equation in terms of U and F and V and F. Okay, so now 2 minutes left. So before finishing the class, okay, so I'll give you a small home assignment, okay. Okay, so you try to find out, suppose the value of R is 30 centimeter, sorry, okay, it's centimeter, R equal to 30 centimeter, okay. So you find the value of F, what? The focal length for concave as well as convex, okay. Is it clear? Okay. So R equal to 30 centimeter, I'm just telling you the magnitude, okay. I'm just telling you the magnitude. The sign, according to the mirror, you have to adjust, okay. I hope it's clear. So I think time is over. So I hope all of you try to practice all these things, okay. You please don't waste your time. And some portion of the optics, say human eye, all these things, and defects of human eye and its all correction and all, already you have studied in class 10. So you don't wait for the teacher. For such kind of topic, you can study. And from the physics, the chapter 15 is that communication system, right? These things are very interesting and only theoretical thing. So you try to study by yourself, okay? Don't wait for the teachers. And as for regarding the physics, okay? Chapter 15 is very easy, and rest of the chapter, you can wait for the class to be resumed. And you please now, because you have lots of time, you try to study bio, English, ALTI, okay? So guys, okay, I hope you like my class or you got everything, and I'll explain in my next class. So time is over.